and then running the analysis, choosing the right analysis procedure. We already talked about this, that we have linear static analysis, modal analysis, response spectrum analysis, P delta, nonlinear static, and time history. And depending upon what you're doing, you should always start with modal analysis first, as I mentioned. Look at the modes, look at all of that behavior, then response spectrum, and P delta should always be included, and then nonlinear static pushover and nonlinear time history. So you can run them gradually one by one, or you can just stop at modal and linear and response spectrum. So up to this one is most common, but P delta should be included for all buildings in all analysis. So checks, like I said, that you should have in mind are natural period checks, mass participation checks, base reaction check, mode shape visualization, period ratio check, and story shear distribution. These are the common checks that you should have in your mind. So you should have some idea how they look like and what the values should be. Okay. So all of these things are going to be very important. Drift, displacement, torsional stiffness, all irregularity checks, then how to get the results back, force results. We get the column forces, beam forces, column, all of the forces, beam moments and shears, then walls, pier forces, PM diagram, and then foundation reactions, and so on. So you get all these forces, and then you need to make sure that you use them properly to do all the checks. Column force variation with height, see how the column force is changing with height. Then shear wall force distribution, because normally shear wall is modeled by a shell element, but we get the forces back by calling it a pier. So it will do the stress integration and put the bending moments back into pier. So you should know how to assign pier labels, how to assign spandrel labels, so that you can get the results back. Look at the story shear profile. This can be very funny. Normally you expect this one, and suddenly it will go up and down. So you should understand what happened. For example, if you put outrigger there, you will find that this plot goes haywire. It's not smooth because the outrigger will shift this drastically. So you will find discontinuities, and you should know why. Should be able to explain them. So wind analysis, we talked about briefly. Code-based design, you need to define many things based on the code that you choose. I think in your design criteria, have you all selected the design code that you're going to use for your projects? Okay, so make sure that you understand the requirements from that code and the load combination factors and everything. So all these are guidelines for you to do the model, and model, the project is your practice. So I don't need to go into the details because you'll be doing it by yourself. So response spectrum ETABS, spectrum definitions, functions, all of that is here. Then verification of the model information, base shear comparison, the load cases, directional combination, we talked about that. So all of that will now become important for you. Linear time history, you can do if you have the time. This is not required. So your project is going only up to response spectrum. If you do anything more than that, you're welcome, but it's not the requirement. So at least up to response spectrum, you must complete. But if you want to do linear time history, anything else, your group can do that. So we already talked about linear versus nonlinear time history last time when I was talking in lecture 4.